Hello again, welcome to my class. My name is Teacher Hura and today is again about ionic equations. Now I've made a previous video on ionic equations, you can check it out. I'll leave a link somewhere here on the screen and you can look at the basics of writing chemical equations. Now just to recap, if you're given such an equation and you're asked to write the ionic equation for that one, the first thing you need to check is that equation balanced. So at a glance, you'll see that the equation is not balanced, especially when you look at the oxygen is only 1 right here, and we have 1, 2, 3, 4 on the other side. So again, the basics of balancing chemical equations, I've talked about them previously. Check out that video. I'll leave the link on the description. So to balance this equation, you need a 3 right here, and then a 6 here, and then a 5 right here, and then finally a 3 there. So that is a balanced chemical equation. So that is the first step you need to check. Then the next thing is to split out any aqueous substances. You see, something like potassium hydroxide is an aqueous substance, then potassium chloride and potassium chloride 5. Now these ones are split into their constituent ions. So you go ahead and see that chlorine is not aqueous, so it remains the way it is. Then of course, now this 6 tells us that you have 6 potassium hydroxide. So you'll have 6 potassium ions and 6 hydroxide ions. As you can see there, now the reactant side is done. So we go to the product side. And on the product side, you find that you have 5 potassium chloride. So this one right here, so we'll split it into 5 potassium ions and 5 chloride ions. And you put your state symbols right there. Then the next thing is the potassium chloride 5. Now many students get to struggle with this one. They don't know how to split this one. So this one you split it as the potassium ion, and the chloride 5 ion is a ClO3 minus. So that one is a potassium chloride 5 when you have split it. So we have the aqueous here and here. And finally, the water remains the same because it is not aqueous. So we'll have to just retain the 3H2O the way it is. Now that is your first step. The next thing is to look for the spectator ions, the ones that remain unchanged on both the reactant side and the product side. So I'll look at this and see that potassium, we have 6 of them right here, and we have 5 plus 1. So that's still a total of 6. So we'll have to cross out the potassium ions because they are the spectator ions. So you'll cross them out like that. Now, whatever remains is going to be your ionic equation. So you just write it down without the spectator ions. And there you go. That is the ionic equation. As you can see, it is a very simple concept. Looking for the right things to do, you first of all have to have the right chemical equation that is balanced. Then you split anything that is aqueous, and then finally cross out the spectator ions and write the remaining equation. That forms your ionic equation. Don't forget to subscribe and also make sure you like the video if you have learned something today. See you next time.